Good evening, guys. I'm going to apologize in advance. We have a ton of vocab words today, so you better stretch out your hands and get ready to write for a little while. And as you write, I'll talk through these vocab words. This lesson is about 1-5, which is square roots and real numbers. So our first vocab word is square root. And a square root is a number that is multiplied by itself to form a product. And what I mean by this is that, say I have 81. I'm going to take the square root of 81. This little sign that I just made, that's called a radical sign, and it means what number times itself is 81. Well, as you know, 9 times 9 is 81. So 9 is the square root of 81. The next thing that leads us to is perfect squares. Now, a perfect square is a number whose square root is a whole number. So 81 would be an example of a perfect square because when you take its square root, you get a whole number. If we make a list of perfect squares here, 1 is a perfect square because 1 times 1, 4, 2 times 2, 9, 3 times 3, 16, 4 times 4, 25, 5 times 5, and 36, which is 6 times 6, so its square root is 6. And the list could go on, of course. It goes on and on. I would say that you'd probably want to know the perfect squares up to 225 is kind of a common one. Its square root's 15. So 225 and below, you should have a good idea of what those perfect squares are. Then the next thing you're going to be doing today is classifying numbers. And that's where the rest of these vocab words come from. These are the definitions of each classification. So again, I'll read through these for you. And you go ahead and write them down. Real numbers are all the numbers that we've been working with, and all the numbers you will be working with. There's actually something called imaginary numbers. That's why we even have to have a classification here. But you won't have to worry about imaginary numbers till you're in high school. So real numbers are all the numbers we'll be working with. Then we have the natural numbers. The natural numbers are also known as the counting numbers. Those are just, they start at 1, 2, 3, etc. There's no fractions or decimals. Then we have the whole numbers. Those are the natural numbers and 0. So they start at 0, 0, 1, 2, 3. And again, no fractions or decimals. Then we have integers. Integers are all the whole numbers as well as their opposites. So that includes the negatives, as you can see. Again, there's no decimals or fractions, but it's all your negative numbers and your positive numbers. Then we have rational numbers. Rational numbers are numbers that can be expressed in the form a over b. So they can be written as a fraction. And b can't be 0, and a and b have to be integers. They can't be decimals. Then we have irrational numbers. Irrational, the way I remember it, is if somebody is irrational, they're kind of crazy. Irrational numbers are kind of crazy. They can't be put into a fraction. They're usually square roots of non-perfect squares and decimals that never stop and never repeat. So some examples would be square root of 2, square root of 11, or pi. Then our last two vocab words are terminating decimals and repeating decimals. Terminating decimals are decimals that stop. Okay? Terminate means to end. So terminating decimals have an end to them. So 1.5, 2.75, 4.0, etc. A repeating decimal, if you'll remember from last year, this bar means repeat. So a repeating decimal goes on forever, but it repeats. So 1.3 repeating means 3's go on forever. 0.6 repeating means the 6's go on forever. And then 2.14, the 1/4's would repeat one after the other. So terminating decimals and repeating decimals are considered rational numbers because they have a pattern to them or they have an end to them. The first thing you'll see in your homework today asks you to find square roots. Now the nice thing about these is that these are going to be perfect squares, so you should know most of them pretty easily. So I have the square root of 16. So again, it's asking what number times itself is 16. And hopefully you know that 4 times 4 is 16, so the square root of 16 is 4. You will also see this sometimes, where you have a negative sign in front of your square root. When that happens, all you do is just leave the negative sign out front and then take the square root. So I have negative the square root of 9. Well, the square root of 9 is 3. So my answer for the negative square root of 9 would be negative 3. We'll also be taking square roots of fractions. Now when I run into a fraction, all I have to do is take the square root of the top over the square root of the bottom. So the square root of 25 is 5, and the square root of 81 is 9. So then the square root of 25 81sts would be 5/9. Now another thing we'll be doing, and these are usually the problems that most kids struggle with, is how to estimate square roots without using our calculator. Okay, so when we come across these problems, there will usually be something about a square. So in this case, we have Shonda. I'm going to make a not very good square here. And she wants to cover a square in glitter. Now her glitter will cover 13 square inches. That's the area of the square. So we want to know what is the side length. We'll call the side length S. Now if you'll remember, the formula for the area of a square is side squared. So if we know that the area is 13, then in order to figure out what S is, we will take the square root. So we know that S is the square root of 13. Now, I need to know what that is. So what I'll do is I'll use my perfect squares. So here's the square root of 13. I want to figure out what two perfect squares 13 is in between. Now 9 is a perfect square, 3 times 3, and so is 16. So 13 kind of falls in between those two. Now I know that the square root of 9 is 3, and the square root of 16 is 4. Now 13 is a little bit closer to 16. So I'm guessing that the square root of 13 is 3.6-ish, we'll say. Now let's check that. Okay, and to check that, I'm just going to do 3.6 times 3.6. And when I do that, let's do a little multiplication here. I get 12.96. Okay, that's pretty close. Now let's just check 3.7 just in case that might be closer. And that gives me 13.69. Okay, so that one's not as close, so that means 3.6. We'll put a little squiggly equal sign, that means approximately. Our side length would be approximately 3.6 inches for our square. Now like I said, this one is one that people have trouble with, so you might want to watch this example again, and if it still doesn't make sense, make a note by it so that you can ask me about it in class the next time you see me. The second thing we'll be doing in our homework today is classifying numbers. Now this chart you'll need to write down in your notes, and it's also on page 34 in your book if you have trouble reading this one. Now what this is it tells you how to classify real numbers. It's a helpful little chart. So you'll need this in your homework. You can see we have natural numbers in the middle here, then whole numbers, integers, and rational numbers. And then the irrational numbers are all over here. Notice also that we have abbreviations that we can use for each of the classifications. If you can memorize those abbreviations, it'll help make your homework a little bit shorter. So this is what your homework will look like. Okay, they will give you a number and ask you to write all classifications that apply. Now notice that a number can have more than one classification, so that will be important. So on this first example here, we have 7 and 4/9. Now that's a fraction, and we know that natural numbers, whole numbers, and integers can't have fractions in them. So that leaves us with rational numbers. Remember, rational numbers can be written as fractions. So this would be classified as a rational number. Now if I remembered my abbreviations, I could also just write Q. That means rational number. Okay, next one I have negative 12. Okay, well we know the natural numbers and the whole numbers can't be negatives, so that would lead us into the integers. So negative 12 is an integer. Now one thing that's important is to know that when you classify a number, it's that classification along with every classification above it in our chart. So if something's an integer, it is also a rational number, because those all fit together. And again, if I remember my abbreviations, I could write Z and Q. And then the last one, we have the square root of 10. Okay, now this, when I see a square root, the first question you want to ask is it a perfect square? So is 10 a perfect square? And the answer is no. 9 is a perfect square, but 10 is not. So when I see the square root of a perfect square, I know right away that this is going to be irrational. All square roots of non-perfect squares are irrational. So that's the second thing you'll be doing, is classifying. So first, again, we got square roots, doing square roots of perfect squares, and then estimating them. That was the story problem I showed you. And then using this chart, being able to classify numbers with their different classifications. Have a good night, and I'll see you guys tomorrow.